Hey guys, it's Jin here, and in this video I would like to explain to you what an ARQ check is and also what an echo check is. Also, Mon will be telling you about another type of data checking which is called parity check. So let's get right into it. So first of all, ARQ check. ARQ check stands for automatic repeat request. This method of data checking is used by following these sets of instructions. Number 1. Sender sends a data packet to the receiver. Number 2. An acknowledgement is sent to the receiver that a data package has arrived. Number 3. The receiver notifies the sender. Number 4. If the receiver doesn't notify the sender in time, there is a timeout. Number 5. The timeout will make the sender need to send the data packet again. Number 6. These sets of instructions are repeated until the receiver notifies the sender. Now let's go have a look at what echo check is. Next is echo check. But before that, what is an echo? Echo is a repeated sound that comes back. So to do the echo check, you need to follow these sets of instructions. Number 1. Sender sends a data packet to the receiver. Number 2. The receiver sends the data packet back to the sender. Number 3. The sender checks if the data sent and the data sent back is the same. Number 4. If not, the whole instruction is repeated. But keep in mind, this is not a reliable method of checking. This is because there is no error checking or trace route being carried out. So now let's have a recap in this video. We learned about ARQ check and echo check, but both of them are not that reliable. So I hope you liked my explanation and hope you understood. And now I will pass it on to Mon, who will explain about parity check. Have fun. Take it over, Mon.
Hello and welcome. Today I'm going to show you how to use parity check and how to find error with parity block. So let's start off first. So what is parity check? Parity check uses parity bit to make sure that the data is or has been sent accurately. And data is sent in bytes, which are 8 bits. Parity are made up of ones and zeros. Parity check can be odd or even depend on how the user sets it. How to use parity check. So first of all, the user agrees if the parity byte is going to be odd or even, so that the user and the receiver can know if there is an error or a mistake. So for example, the user decides on a parity byte to be odd and give 10101000, and so you add all the ones up, which will give 3, which is odd. So that's how you use parity check. So next, how to use parity block. Parity block is the first line vertical and the bottom line horizontal, and it needs to be both have to be odd or even. Even if parity block is both odd or even, if the bits change place, it will make an error. So let's take a look at for example. So here's an example of a parity block. So parity block consisted with parity byte on the horizontal and parity byte on the vertical. So I went with the parity bytes to be even. So there's a 1, 2, 3, 4, 5, 6, 6 one, which is an even, and on the vertical there is 1, 2, 3, 4 ones, which is also even. So the bits and the bytes are supposed to add up all together to be even. So let's take a look for byte 1, which consisted with 1, 2, 3, 4, 5, 6, 7, 8 ones, which is an even number, so that is correct. On byte 2 there is 1 and 2 ones here, so that's an even, which is also correct. On byte 3 there is 1, 2, 3, 4, fourth one, which is also an even, so that is correct. On the fourth one there is 1 and 2, So 2 ones, which is also even, which is correct. And on the 5th byte there is 1, 2, which is also even. And on byte 6 there is 1 ones here, so it's wrong here, so that's an odd and it's incorrect. On byte 7 there is 1, 2, 3, 4 ones, which is an even, so that's correct. Let's take a look on the bits here. So bit 2 there is 1, 2, 3, 4, 5, which is odd and it is incorrect. On bits 3 there is 1, 2, 3, 4, 5, which is odd and it is incorrect again. On bit 4 there is 1, 2, 3, which is incorrect, and 5, 1, 2, which is correct. And 6 there is 1 and 2, so that is correct. On 7 there is 1, 2, 3, which is incorrect. So on 8 there is 1, which is incorrect. So how to make it correct? So you just add in on ones on any zeros here, so make it an even number, so the bits and bytes are even. So yeah, hope you guys learned something new, and we'll see you guys very soon.